Okay, so picking up from this problem, we've got negative 2 to the fifth power times p to the 15th s to the 10th. This is pretty much done. We could add a little bit more here by recognizing that this is negative 2 to the fifth power. And I should have probably put parentheses around this and left it that way because negative 2 to the fifth power would be negative 2 written out 5 times multiplied together. Well, 2 to the fifth power is 32. Negative 2 to the fifth power, since I'm multiplying 5 numbers, that would be like this: a negative 2 times a negative 2 times a negative 2. I'm getting there, people. Negative 2 times a negative 2. Let's think about this. Negative 2 times 2 is a positive 4. These guys come together to give me a positive 4. This negative 2 is still here. 4 times 4 is 16 times a negative 2. You got it, is a negative 32. So negative 2 to the fifth power is a negative 32. And then I'm left with p to the 15th and s to the 10th. And this is my final answer. Let's take a look at part C. In part C, we've got this 4 on the outside. And if we think back to like rule number, I forget which number it was. Let me take a quick look. Here we are. Rule number 5. This reminds me of rule number 5 because I'm got a quotient here and I'm raising one thing to this thing to one power, and therefore each thing inside needs to be raised to that power. So we have that same situation here also with the other rule, with the rule just before it, the rule number 3 or something. So we know that 4 is going to have an effect on everything in here since it's all being multiplied and divided. So we've got negative 3 to the fourth power times x to the fourth power, all of that over y to the fourth power. Negative 3 to the fourth power, that's going to be four negative numbers multiplied together, which will ultimately give me a positive number. So negative 3 times negative 3 is positive 9, and a negative 3 times negative 3 is positive 9. So 9 times 9 is 81. So I get 81 x to the fourth power over y to the fourth power. Our final one is this guy over here. Let me get a little bit more space so that we can kind of look at this. So I've got a to the fourth over a over 4, excuse me, to the negative third. Now this negative 3 is going to affect everything inside. There's a couple of ways to handle this problem, and I want to talk about it. One way, we can kind of do what we've been doing, a to the negative third over 4 to the negative third. But then we get this weird thing where we've got a number to a negative power, and we know that from rule like number, I don't know, remember 7, if we have m to the negative 2, it's equal to 1 over m to the second power. So that tells me that this a to the negative third will be dropped into the denominator. But what's going to happen to this 4? Well, the fact is, the short answer is that the 4 will actually be raised to the numerator. So what happens here is the a goes into the denominator, kind of as expected. Drop it down, make the exponent positive. But if you have a negative exponent in the denominator, you raise it to the numerator and you make it positive. So in a sense, wherever the negative exponent is, it's almost like it's unsettled and it needs to move to the next place. So if you're in the denominator with a negative exponent, you move to the numerator and it becomes positive. If you're in the numerator with a negative exponent, you drop it to the denominator and it becomes positive. So this in essence is the answer. 4 to the third power, 4 times 4 is 16, 16 times 4 is 64. We end up with 64 over a to the third power, right? Not too bad. It looks a little bit like a 9. Let's make it look like an a. If we come over here, there's another way to look at this. This negative exponent really means take the reciprocal. So reciprocal, remember, is if I have a over 4, the reciprocal of that would be 4 over a. So it's a flipping situation. So what happens here is that the negative exponent basically tells me to flip it. So I could literally look at this a over 4 to the negative third power as 4 over a to the third power. And therefore I get 4 to the third power over a to the third power, where we already talked about 4 to the third power being 64, and I'm left with exactly the same answer. Either pathway is totally fine. So what we realized here, something we didn't talk about, is if you have a negative exponent in the denominator, put it in the numerator, make it positive. Or if you have a negative exponent, you can just automatically take the reciprocal of that fraction or that number and then go about your business with a positive exponent. In your text, this example had two different methods, and to be honest, there's like a lot of different ways to attack these problems. One way that we could look at this problem, I'm going to call it method one, it might not be identical to what they did in the text, is to simplify what's going on inside and then deal with this 4 on the outside. And so we know that this 4 is going to have an effect on everything, but let's simplify what's going on inside. So we have this confusing looking expression, but we can handle it. We see that we've got the same base here with the with this x value. So I'm going to just highlight that. So I've got that x there. When I've got the same base and I'm dividing two things, I can subtract those. So I can look at this as negative 2 times x to the, well, what's 3n minus 2n? 3n minus 2n is just n, and that y stays down there in the denominator. Now I can deal with the 4 and go ahead and apply the 4 to everything inside because everything's being multiplied or divided. So negative 2 to the 4th power times x to the n raised to the 4th power times y to the 3rd power raised to the 4th power. And we remember the power to power rule, so that's going to be affecting it here. Let's deal with this first though. Negative 2 to the 4th power is going to be a positive 16. So if I wrote negative 2 4 times and multiplied it, I'd end up with a positive 16. And then x to the n is going to, x to the n to the 4th power is going to end up being x to the 4n, right? Because power to power rule tells me to multiply. And then this guy, y to the 3rd power raised to the 4th power, is going to be y to the 12th. And so my final answer is going to end up being 16x to the 4n, y to the 12th. And I'm done. Now, the other method is just to look at it a little bit differently. So starting off with that same problem, we're just going to raise everything to the 4th power. So negative 2 to the 4th power we know to be 16. X to the 3n raised to the 4th power is x to the 12n over x to the 2n to the 4th power is x to the 8n. Remember, power to power tells me to multiply. Y to the 3rd power raised to the 4th power is y to the 12th. And then so now I've got this same situation where I've got the same base, that x, and I'm going to subtract the exponents. So I end up with 16. 12n minus 8n is 4n. So I get x to the 4n, and in the denominator, we're still left with y to the 12th. So you notice we get the same answer either method. Your text may have done something a little bit different, and there's often a lot of different ways to handle these problems, but just know that you'll get the same answer as long as you use the rules correctly. Let's take a look at another example. I just realized that we did not talk about some of these couple of vocabulary terms. So let's just get that together. Standard notation is writing a number as we generally do, like 6,345 would be standard notation. But scientific notation, you have the number written in a way such that it is a number multiplied by 10 to a power, and the number must be between 1 and 10. So it could be 1 equal to or greater than 1, right? The number that I'm going to put here, or this number must be less than 10. So what does this mean for, let's say, the number that we have written here, 6,345? Well, if I wanted to write this in scientific notation, I would take the decimal point, move it back 1, 2, 3 spaces, and write it as 6.345 times 10. How do I undo what I just did? Well, I'd have to move the decimal point to the right 3 spaces, meaning multiplying this by 1,000. And in order to do that, I'd have to raise this to the 3rd power, because 10 to the 3rd power is 1,000. And I know this seems really kind of complicated, if you've never seen it before. But once you start practicing it, you get the hang of it. It'll make total sense. So what you'll notice is that the way that you move this, the fact that I move this 1, 2, 3 spaces back, really tells me what my exponent will be. And so we'll talk about scientific notation right now. So each of these problems, each of these numbers are written in standard form, a way that we're used to, 6,380,000. And here we have, let's see, tenths, hundredths, thousands, 10,000s, hundred thousands, millions. This is 47 millions. Let me make sure. Tenths, hundreds, thousands, 10,000s, hundred thousands, millions. Yeah, this is 47 millions. So we can, I'm never really good at saying those numbers. I'd prefer to say 0.000047, but trying to be good here. So we've got these numbers written as standard form, and we're going to write them in scientific notation. So remember, it's going to be some number times 10 to some power. And this number must be between 1 and 10. And so it can be as small as 1 and it can be as large as 10. Let's say if we call this number, let's say some number x, okay? And so x has to be somewhere between 1 and 10, and we'll figure out the exponent depending on how we adjust this number. So if I'm going to write this, I'm going to move the decimal point over 1, 2, 3, 4, 5, 6. 6 spaces to the left. So I'm making the number really small. So this number is now 6.38 times 10 to the, now I've got to kind of undo what I did. If I move the 6 places over to the left, when I'm making it back into the number that it is, right, I'm going to multiply it by 10 to the 6th power. So I'd have to make sure the decimal place gets moved 1, 2, 3, 4, 5, 6 places in order to get back to where it should be. So this is how I would write 6,380,000 in scientific notation. Well, let's check out this 47 millions. So in order for this guy to fit the standard where this number must be between 1 and 10, I've got to move the decimal place to the right. 1, 2, 3, 4, 5. So I'm going to get 4.7 times 10 to the, now not 10 to the 5th because of the direction I moved it. Since I moved the decimal point to the right, if I had to undo this, I'd be pushing it back to the left. And that means we're going to make it smaller. So I'm not going to move it 5 times. I'm going to move it negative 5 times. Now, talk to me about this if this is really kind of confusing. Why is it negative and positive? I'm kind of assuming that you've seen it before. If you haven't, that's okay. We can talk about it and make it plain. But basically, these two examples are pretty much what you need to know about changing a standard number into a scientific notation type of number. Here in example 6, what we're doing is we're going to be multiplying numbers in scientific notation. And so it's not going to be too hard, but we just got to be patient and take our time a little bit. So we're multiplying 4 times 10 to the 5th times 2 times 10 to the 7th. Technically, you got to think about this as you're multiplying 4 times a 10 to the 5th times a 2 times a 10 to the 7th. And I hope rewriting it like this shows you that you literally can multiply the 4 and the 2 to get 8, right? So we do that. Then we multiply 10 to the 5th power times 10 to the 7th power. Well, we've got the same base. This is a situation where we've got the same base. And what do we do when we have the same base and we're multiplying numbers? We add the exponents. So this is now 4 times 2, 8, times 10 to the 12th power. So this is our answer. Why do I know I'm done? Because we want the result in scientific notation. And we remember that scientific notation is simply multiplying a number times 10 to a power. And that's what we got. And that number is between 1 and 10. Let's do this last one. Similar to the last problem, 2.7 times 3 gives me 8.1. And then I multiply these guys together. Well, I've got to add those exponents. This is going to now be 10 to the 6 plus negative 2 is going to be 4th power. And since it fits the pattern of the standard notation, the scientific notation, I'm good. And we're done. All right, that should be enough to get you through the assignment, which would be pages 226 through 228. 19 through 55 odd, and these last few review problems 72, 77,